Howdy, Tigers! Today we're going to learn about systems of linear inequalities. I can graph a system of linear inequalities on a coordinate plane. I can check points in the intersection of the solution area to verify that they represent a solution to the system. Remember that the ordered pair has to satisfy not one, but both of the inequalities, just like when we were working with equations. Solve each system of inequalities by graphing. So again, what we're looking for is the area on our coordinate plane that satisfies both inequalities. How are we going to do that? Well, we're going to approach y is less than negative x plus 3 the same way we would approach it if it was y is equal to mx plus b. So in other words, I'm going to pick out my m and I'm going to pick out my b because it's already in slope-intercept form. The m is -1 and the b is 3. So I'm going to start at the origin and I'm going to go up to 3. My slope is -1, so that means down 1, right 1, down 1, right 1, and that process repeats itself. Remember, not only can I go down 1, right 1, but I also can go up 1 and then back 1. That's going to keep my slope negative. From here, we have a very important decision to make. We have to decide if it's going to be a solid line or if it's going to be a broken line. You remember from graphing inequalities that less or greater means that it's going to be a broken line. But if it's less or equal or greater than or equal, then it's going to be solid. So this inequality is going to be a broken line. From here, I have to determine which side of the line I'm going to shade on. To do that, I need a test point or a checkpoint. An easy test point is 0, 0. When I substitute in 0, 0, then it's going to look like 0 is less than 0 plus 3. So 0 is less than 3. Because that's a true statement, then I'm going to shade on my test point or over my test point. If it was false, I would shade on the right side of the line. In other words, on the opposite side than where I chose my checkpoint. I would highly suggest for you to do the problems in the order I'm doing them in. In other words, we're going to graph by determining if it's a solid line or a broken line, and then go ahead and shade. Go ahead and do that with each inequality. For the second inequality, I can't graph in standard form even though it's already in standard form because it's equal to 0. But what we know is that this line will go through the origin. So I'm going to go ahead and turn it into slope-intercept. I know when -2x crosses the greater than sign, then it becomes a positive 2x. Divide through by the coefficient of 4. Y is greater than 1/2 x. And as expected, it does go through the origin. So my slope is 1/2 and my y-intercept is 0. So from the origin, I'm going to go up 1 and over 2 and repeat that process. Or down 1 and back 2. You don't have to have this many points. It's just easier to use my tools when I have more points. So once again, I have to determine if it's a solid line or a broken line. It's equal to, so this line, unlike our first line, is going to be a solid line. Last step, now we have to determine which side of the line I'm going to shade on. So I'm going to just choose a point. I cannot use 0, 0 because it goes through the graph. So I need to use a different ordered pair. So I'm just going to go ahead. I'm going to use the point, maybe just right here above the line. I'm just going to use the point 1, 1. So when I go back and I substitute it in, then I'll have -2 times 1 plus 4 times 1 is greater than or equal to 0. So we have to see if that's true or if it's false. -2 plus 4 is greater than or equal to 0. 2 is greater than or equal to 0. That is a true statement. Therefore, I'm going to shade above the line. So what I'm looking for is the overlap of the red and the blue. So only the part that we see that is red and blue, that is the part that is our solution. So just to make sure that we did this correctly, I'm going to just choose a point in that area. Let me choose, go back to the origin. I'm just going to choose -1, 2, 3, 4, -4, 1. Okay, so from here then I need to test it and to see, you don't have to do this every time, but we're just proving that it works in this case. So -4, 1, I'm going to plug it back in to the equation. So that's 1 is less than -4 plus 3. 1 is less than 7. So that one checks. Let's see about the second inequality. -2 times -4 plus 4 times 1 is greater than or equal to 0. So now we have 8 plus 4 is greater than or equal to 0. Well, of course, that one checks as well. We did a good job. Give yourself a pat on the back. Let's go to the second example, and we're going to do the same thing. Now, both of these inequalities are really nice because we can just graph them in standard form. So I don't know about you, but if I can graph in standard form, I'm just going to go ahead and do that. So I'm just going to break this up just a little bit here. I'm going to make this a little mini table of values. That's what I call it when I graph in standard form, because I only need 2 coordinates in order to do that. I need a 0 in for x and I need 0 in for y. When I substitute in 0 for x, then that means that 4 times 3, that's going to give me 12. When I substitute in 0 for y, that makes this all 0. That means that 6 times 2 gives me 12. And I'm just going to stay with this inequality to begin with. In other words, I'm just going to talk about my first one, not my second one yet. All right, so to graph, then I'm going to go to my origin, go 0, 3. That's my y-intercept, and then my x-intercept is 2, 0. Solid or broken? Well, this is going to be, you may have guessed it, it's going to be a broken line. And I only need those 2 points to determine, try it again. That's a little better. To determine a line. So 2 points makes a line. We only need the 2 points to create our line. But now I need to determine which side of the line I'm going to shade on. So I know when I substitute in 0, 6 times 0 is 0. And when I substitute in my test point is 0, 0. 0 plus 0 is greater than 12. Well, that's a big no-no. That is a false statement. Therefore, I don't want to shade at my test point. I want to shade on the other side of the line. I don't know if you're going to be able to see that very well. Let me try it. Oop, big one. So remember, you're shading on the side opposite when the statement is false, because I want to shade where it's true. So because 0, 0 is false, then I'm shading on the other side where it's true. Sound good? All right, and again, I would encourage you to do it in the order that I did this in. In other words, I'm not going to wait to shade. I'm going to go ahead and do that now rather than waiting to graph and do that with my second inequality. So speaking of second inequality, all right, we need a mini table of values again. So if -3 times 0 is 0, this is 0, then that makes this a 3. And then when I plug in 0 for y, then that makes -3 times -4 is 12. Excuse me, so 0, 3, and then same point as before. Let me get a different color. And then 1, 2, 3, 4, 0. Solid line or broken line? Well, just like before, it's going to be a broken line because it's greater than. Last step, we want to determine which side of the line we are going to shade on. Can I use 0, 0? Sure, I can. So once again, when I substitute in 0, negative 3 times 0 is 0, plus 4 times 0 is 0, is greater than 12. Well, if it was false last time, it's probably false this time. So don't shade at 0, 0. We want to shade. Let's see if I can, let's do blue. At least maybe you can see that a little better. Not so much. But we're looking for the overlap of the green and the blue that kind of combine together. So I'm going to mark that for you a little better. So we're talking about this area that is the overlap. I hope you really enjoyed your lesson on solving a system of inequalities today.